So the another problem related to thin cylinders. Okay, problem 4. So a thin cylindrical shell, a thin cylindrical shell with following dimension with following dimension is is filled with a liquid is filled with a liquid at atmospheric pressure at atmospheric pressure, length 1.2 meter, my external diameter 20 centimeter, thickness of a metal, thickness of a metal is equal to 8 m. Find the value of the pressure. Find the value of the pressure exerted by the liquid on the walls of the cylinder and the hoop stress induced if an additional volume of 25 centimeter cube of liquid is pumped into the cylinder. Take E is equal to 2 into 10 to the power 5 Newton per mm square, and Poisson ratio mu is equal to E equal to 2.1. Okay, Poisson ratio mu is equal to 0.33. So the given data are, okay, that uh, the length L is equal to 1.2 meter, so this is 1200 mm. External diameter capital D is equal to 20 centimeter, which is nothing but 200 mm. So here they have mentioned that thickness T is equal to 8 mm. So therefore internal diameter small d is equal to capital D minus 2 times of thickness. Okay, then it becomes 184 mm. 184 mm. Then they have given that find the value of the pressure intensity. So P we have to calculate. Then if the hoop stress on the wall, the cylinder, the hoop stress induced if an additional volume of 25 centimeter cube of the liquid is pumped into the cylinder. Okay, so additional volume, which is nothing but additional volume. Okay, that is change in length means sorry, change in volumetric strain is nothing but change in volume divided by original volume. So this additional volume I'm going to take it as a change in volume. Okay, is equal to 25 centimeter cube. So this is nothing but 25 into 10 cube mm cube. That is our additional volume. Okay, then remaining they have given x modulus E is equal to 2.1 into 10 to the power 5 Newton per mm squared, and mu is equal to 0.33. So let us move on to the solution part. So here we have to find out what is the internal pressure P, and the hoop stress sigma 1 is equal to what? That is our calculation part. Okay. So first we should move on to the formula, that is volumetric strain, that is change in volume by original volume. So change in volume, they have given that 25 into 10 cube mm cube. Okay, and volume pi by 4 into d squared into L. So whereas pi by 4 into d value is how much? 184 mm, and L is equal to 1200 mm L. Okay, so if I'm going to multiply these things, pi by 4 into 184 squared multiplied with 1200 mm, so it becomes 31.909 into 10 to the power 6 mm cube. Therefore, del V by V becomes, okay, so 25 into 10 cube divided by 31.909 into 10 to the power 6. So it becomes 0.000783. Okay. So we know the formula, change in volumetric strain del V by V is equal to P into D divided by 2TE into 5 by 2 minus 2 mu. So if I am going to substitute these values, 0.000783 is equal to P value, I don't know, so I have to calculate. D value, they have given that 184 divided by 2 into thickness. So thickness is 8 mm into young smallest 2.1 into 10 to the power 5 minus, sorry, divided by 5 by 2 minus 2 into mu 0.33. So if I'm going to substitute these values, I can get the value of pressure intensity P. Okay. So pressure intensity P I have to calculate now. 783 multiplied with the 2 into 8 into 20 to the power 5. So this answer divided by 184 into 5 by 2 5 by 2 minus 2 into 0.3. So it becomes 7.400. So pressure intensity is equal to 7.40 Newton per mm square. So this is the internal pressure of the particular fluid in the cylindrical shell. Next we need hoop stress. So hoop stress or circumferential stress sigma 1. So sigma 1 is equal to P into D divided by 2T. We all know that. So P value is calculated at 7.4. D value is 184 mm. 2 into thickness is 8 mm. So if I'm going to substitute these values, I can get the answer of 85.1. So sigma 1 is equal to 85.1 Newton per mm square. So this is the answer for our given question. Thank you all.